Hello everybody, and welcome to the third and last video in the second playlist. My name is Anton, and as usual, Raj. Raj, say hi.
Hello.
Yep.
Hello.
And today we will be talking completely about 3D printing and how to do it correctly, and also the procedure of doing it with the FRC printers. So, the 3D printers that we have in the shop for FRC right now is FDM printing, or fused disposition modeling. And basically, what it does is it takes a roll of plastic that has kind of like this thread of plastic rolled onto it, and then melts it, and then extrudes it out of this nozzle at like very, very high precision. So like 0.2 millimeters, like it could be, yeah, like a 0.2 millimeter nozzle. I think that's what we have on our printers, and can create pretty complex in basically pretty complex in any part that you want for your robot. So for FRC, what this is mostly used for is a lot of mounts and of course spacers. For FTC, I know that this will be definitely used for spacers. Raj, what did you use it for last year?
We use it for our part of our intake as well as part of our outtake as well.
Custom parts of your robot as well, especially for FTC and also spacers. And what it usually does is it like prints out a really nice part, like this boat right here. Or sometimes it goes straight to Italy and makes a nice bowl of spaghetti for you, kind of like that. And this is usually the fault of the person who's starting the 3D print and not really the design's fault. So if this happens, don't worry about it. It's not your fault. FDM printing isn't the only type of printing. There's also SLA printing that we do not have. I have no clue what SLA printing does. So you pour resin into a 3D printer, and then they shine a laser, or as Raj said, a UV light onto specific parts of that resin, and then the parts that were had the lasers shine on them harden, and then when you take the part out, it comes out as a solid part. Um, these are well, SLA printing creates very accurate and smooth and strong parts. You can definitely create gears out of them and not really worry about them. Um, you can also make like small parts as well, since it's a laser that is pretty small. But it does cost a lot more than FDM printing. It is pretty hard to use, and can get pretty sloppy, especially with the liquid resin. And includes more post processing than FDM printing. FDM printing, on the other side, is something that we do have. We have two printers, which we will talk about later. As I said before, it just melts plastic and then builds a part. It specifically layer by layer. That is so it lets other uh, portions of the 3D print to cool. It is pretty cheap to buy, and then pretty also really easy to use, especially using the Bamboo Studio. FDM printing does create pretty brittle parts compared to SLA. Like, I would not generally trust gears, especially ones that have a lot of torque on them, because they will probably break. And it does not have really good resolution, because since it prints layer by layer, you will definitely see the layer lines on your 3D print, and those can also sometimes get a bit off centered, resulting in inaccurate parts. Moving on. So these are the printers that we currently have. We have the Bamboo Lab X Carbon X1C and the Bamboo Lab P1S. So the X1C is basically more advanced than the P1S. It can do more kind of more advanced materials such as carbon and TPU, which is basically rubber. I think and it can also print faster and more accurately than the P1S. I think the P1S can do rubber, but I don't think it can do carbon. But they can both print in multiple colors. So for you guys, it'll probably be orange, unless you guys decide to have a mix of colors. But yeah, and this doesn't mean that the P1S just basically sucks. It still is a really good printer, and you can find them both in P1 right next to each other. So the materials you guys, well, we can print is PLA, uh, that which I will not say. I will actually just say carbon fiber nylon, which is really, really strong. Carbon fiber, if you guys don't know, it's stronger. It's a lot stronger and a lot lighter than aluminum. It's kind of like polycarb except on steroids. And TPU. TPU is, as I said before, rubber, and I will go through where you might want to use each of these. So PLA is the most commonly used material, both in FTC and FRC. It's really, really good for prototyping because it doesn't cost a lot. It's really, really easy for post processing. You quite literally just like yoink it out of the printer and start using it. Yeah, like it's basically just the go-to material, kind of like 6061 aluminum is the standard of FRC. Carbon fiber nylon, as I said before, is a lot stronger than PLA. I would use this material more for gears that expect high torque, and also for parts that expect contact. So you can also just protect parts from contact or use them for parts that do expect contact. Again, I don't know if FTC will need carbon fiber nylon because I don't know if you guys will be getting a lot of contact, but if you guys do suspect a part to go under a lot of stress or possibly crash into a field and break, you could try to use carbon fiber nylon. Um, and some tidbits for carbon fiber nylon is we can only print it on the X1C, and the filament needs to dry before the print. We actually have a dehumidifier in P1 because we have to actually place the roll of carbon fiber inside of it to get all the moisture out of it, because if you put the carbon fiber inside of the 3D printer while when it's not dehumidized, it's not gonna go well. Yeah, it's just gonna basically spaghettify and book a direct flight to Italy. And it does take a whole day to make because it does need to dry after the print as well. So we basically lose the X1C for a whole day, but it's pretty chill and pretty worth it as well. So if you do plan on using carbon fiber nylon, don't just print like one part. Try to print like many iterations of that part or other parts that you guys want to make out of carbon fiber. And then TPU is a more rubbery material. These are more common for wheels in FRC. Um, so, for example, intake wheels, you can easily create custom intake wheels. Raj, I don't know how useful this would be to create custom wheels for FTC.
Yeah, I mean, typically we don't need custom wheels, so it's probably not too useful. But I mean, you never know what the challenge could be.
Yeah, exactly. So it's always nice to have it on hand, and it does only work on the X1C. So 3D printing is definitely an iterative process. You definitely will have to create many parts to get to the final iteration. I will promise you that the first part you create when 3D printing is definitely not going to be perfect. I I know Raj has a lot of experience with this, based on
We
the
have a
document
lot
he
of
just
experience with
yeah,
this.
based on the document he just showed me, which we will look at later. So yeah, and then if you are trying to make a part out of carbon fiber, a really good practice is to make the part first out of PLA. Just make sure you have all the dimensions correct and all the aspects of your part correct, and then for your final iteration after you've um, finalized it with PLA, then you can make it out of carbon fiber. Fillets are really, really, really important in 3D printing because you want to add fillets when you want to strengthen the walls of parts, specifically on corners. You do not want to have sharp corners, like sharp inside corners on a part, because they will break. I know this does not seem like very intuitive, but I promise you, we had a lot of experience of parts with sharp corners breaking in FRC like 2 years ago, and yeah, so the reason why you want to add fillets onto a corner is, let's just say for example I have a part that is something like this, right? And it's basically a wall. So this is top down view, right? Here's the outer wall and here's the inner wall. So you putting fillets on the outer wall is a good practice, but it won't really necessarily strengthen your part because you already have all this material on the inside of the walls, right? But you really want to try to strengthen this inside corner because right now, if you just go from the top all the way to the corner, you'll see that the directional change of the corner is instant, right? It goes down, 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 oh, going to the right. So when you do put force, let's just say you put a torque this way, right? All of this torque is going to be focused on one specific point of the part, and that is a lot of force on that specific point of the part. So it might just quite literally break in a straight line, kind of going across like that. So it's definitely no bueno. To fix this, you want to add a fillet because a fillet distributes the forces that are applied onto that corner, right? Now, if I apply this torque, it will be like the forces will be mainly like what just it'll be just distributed more evenly, right? Because it's not like a point; it's actually just a really curved line that eases into the turn. Raj, any questions?
Yeah, I guess like the question is like, how big do you typically need this fillet to be?
That is a good question. Um, I will say to I know this sounds stupid, but I will say to eyeball it. You do not want to make it too small. Like for example, let's just say this wall, like the thickness of this is a quarter of an inch. I would probably make this fillet a quarter of an inch, point 0.2, point 0.1, something around there. Like it all depends on how much space you have around the fillet because it does add material onto your part. So, yeah, I would just gut feel it. And if you are unsure of what to make it, again, you can ask me or Sean or Akil. Yeah, like for example, for this corner, you definitely do not want to make like a fillet that's like this, right? Because that's just a waste of material, right? So probably like a quarter of an inch should be fine. This is an example of a part for FRC where you should try to add some strengthening fillets. So see how for this little handle over here, the fillets are on the inside, right? Because they connect to this kind of ceiling. And these parts, like these sharp corners over here, will definitely experience a lot of force on them, as well as this one over here. So yeah, just any inside corners or any turns that are really susceptible to breaking. And I know this might be sound confusing right now, but it just takes a lot of time and a lot of practice. And again, I'm always here. Akil's always online, and Sean is also there. So just ask any one of us, and we'll help you out. Okay, so wall thickness is also plays a pretty big part on in robotics in general. So you definitely want to here are some general rules for the wall thicknesses. Like if you are trying to create a mount for something, I'm not sure if you would need to make a mount for something. 3 to 4 millimeters is fine. If you want to make a part on the robot that might expect some contact, you really want to try to make the walls 6 millimeters minimum. But for FTC, again, I don't know how much contact you will experience, so maybe 3 to 4 or 5 millimeters for the thickness of the walls should be fine. So we talked about this a bit in the last video. Clearance is really, really important, especially for 3D printing. You will definitely experience problems with clearance when you're first starting out to 3D print. I definitely did. A lot of people I know in FRC did. So it just kind of needs to be implanted in your head just to make sure to always add clearance. The same with holes as well, right? I do not want to dimension this wall right here too close to the hole because then that is definitely susceptible to breaking. Nor do I want to make it too far from the hole because that is just another waste of material and a waste of time. Getting the dimension right also, like I would just say, rely on your gut feeling. Again, a lot of gut feeling right now with CNCing and 3D printing, but that's just how we do things. So creating 3D printing parts is a really good practice of designing with intent. What this means is you really want to think about how you start your design and how you will continue it, right? So for example, let's just say I'm making this water bottle, right? Like how will I start it? Will I start it from the top view and then just make a cylinder and then just start carving away features? Or will I go to the right plane and then sketch one half of it and then revolve it around the center line over here to make the water bottle, right? Like, again, every approach is correct, but you really want to find the most efficient approaches to create parts. And making parts changeable is very, very important in 3D printing because, again, you will definitely make iterations in your parts. Um, this means that if you change one dimension in your whole part does not turn red. You definitely do not want that. So, this is why geometric constraints are better than dimensional constraints because they allow more play with the geometry of the part than just using the dimension tool. Moving on to Raj, you want to talk about this part that you created
Yeah,
last season?
so this part was our outtake from last season. Basically, it was kind of like a bucket where you would place a sample, which is kind of like a brick, and the bucket would tilt backwards, dumping the sample into the basket. So we went through a lot of iterations over this design as we realized like some of the weak points and changed certain aspects of it. So I guess if you want to start with V2. Yeah, so this was basically kind of a version of our first design where it would tilt sideways and we would dump it into the basket. And in the version that you're looking at, version 7, it tilts backwards instead. And you
So
can also see that that attachment point over there is separate from the basket itself.
this one,
One change that we made during, yeah, one change that we made during this shift was making our slide a lot faster. And what we noticed what would happen is this piece, if caught on the bucket, would break off. And to not damage the servo or anything else, we made it like a break point. That way we could replace this if need be during our competition. So these are just some areas of like changes and iterations that we went through for 3D printing in general. But I mean, we did have our fair share of struggles as well in terms of clearances and other aspects as well.
yes. So that is a very, very good point. Sometimes you want to make your 3D parts breakable because if they do not break, then more important mechanisms of your robot might break, right? As Raj said, then his servo might have broken if this part did not break. Maybe even like some part of its structure might even just snap in half if this didn't break. This also applies not
Yep.
only to 3D printing parts, but also to like metal parts as well. You really want to make sure that the first breaking point is a really easily replaceable part and is not too important to your mechanism. And again, if it is, you definitely want to make it replaceable. Like this part is. Like Raj, I'm assuming you just printed like 5 of these and would just switch them out whenever they broke.
Yep.
Yeah,
Exactly. Exactly.
because if and then I'm assuming did this slide break a lot?
Not the slide, but if that part got caught on like the bucket, right? It would like try and come down and
Yep.
then get caught, and basically this piece, the breakaway point would snap instead of like it bending the servo or breaking the bucket.
Yeah, exactly. So instead of breaking the slide, this thing would just snap, and then they just easily just put another one onto it and call it a day. So now I want to talk about how to the procedure for FTC printing. It is basically the same as CNC printing or as CNCing, where Akil will have a form for you to fill out, which will ask you what you want to print, and you'll have to attach the link to it. And then it will prompt you with some questions to make sure that your part is 3D printable. So you will have to meet some guidelines, and then your team will also have to provide their own filament. You will not be able to use FTC filament unless there are some exceptions. I think Akil has exceptions. I'm not too involved in that process, but I'm pretty sure Raj, you guys already have some of your own filament.
Yeah, we do. We have
Yeah.
some of our own, and we
So
can obviously order more if necessary.
exactly, and it could be of other materials like carbon fiber or TPU if needed. So thank you again for watching, and we will see you in the next playlist where we will start going into assembly.